Welcome to this lesson on Laplace transforms of Heaviside step functions. We'll solve several problems involving the Laplace transform of shifted step functions and their combinations with other functions. Let's start with our first problem, proving that the Laplace transform of h, ta, equals e to the negative s over s. Here, h, ta, represents the Heaviside step function shifted a units to the right. To prove this, let's start with the definition of the Laplace transform. The Laplace transform is defined as the integral from 0 to infinity of e to the negative sd times our function h of t minus a dt. Since the Heaviside function is 0 before t equals a, we can change our lower bound to a. Now, let's evaluate this integral. The integral of e to the negative sd is negative 1 over s times e to the negative street. Evaluating from a to infinity, and noting that e to the negative st approaches 0, as t approaches infinity, we get our result, e to the negative s over s. For our second problem, we need to prove that the Laplace transform of h, ta, times fta equals e to the negative s times phi of s. This is a generalization of our first result. Let's solve this using a change of variables. Let's substitute tau equals t minus a. When t equals a, tau equals 0. And when t approaches infinity, tau approaches infinity. This gives us e to the negative as times the Laplace transform of f, tau, which is phi of s. For our fourth problem, we need to evaluate the Laplace transform of a polynomial times a shifted step function. Let's break this down step by step. First, we need to express our polynomial in terms of t2. After expanding and collecting terms, we get 4, t2 superscript 3 plus 21, t2 superscript 2 plus 38, t2 plus 25. Now we can apply the time-shifting property and multiply by e to the negative 2's. Finally, using the properties of Laplace transforms, we get our result, e to the negative 2's times the sum of 25 over s plus 38 over s squared plus 42 over s cubed plus 24 over s to the fourth. These problems demonstrate important properties of Laplace transforms with Heaviside step functions. Remember that the time-shifting property and careful handling of bounds are key to solving these types of problems.